So good idea here on these problems when there's no adding and subtracting at all, just simplifying. Break it up into like 3 smaller problems. So we have the 12, the number part, we have the A's, right? That's like its own problem, and we have the B's, and that's like its own problem. So ending point in math or anything at all, if you break it up into smaller parts, it's probably easier. So I think does 12 simplify with anything? Say nope. And does A over A to the second simplify at all? Say yep. One at the bottom now. That A just cancels out one of these. Same thing with B's. That B cancels out one of these. And that's it. So breaking it up into smaller pieces, just the numbers by themselves and each variable by themselves. Same thing here. Numbers by themselves. Factor the 21, factor it to 7 times 3, and the 7's cancel out, so there's a 3 left on the bottom. And then, of course, the 3 n's cancel out with 3 of these here, so there's 5 left over. And if there's ever anything empty, like on the top, you will 1. Just like that. So understand, this is factoring. When I take something and I write it as a product or two things being multiplied, that's what factoring is. We're doing this with polynomials where we get the x plus 7 and x minus 3 and that kind of thing. But it's the same thing as we did a long time ago. Broken into smaller parts that are being multiplied and cancel anything that's the same. And down here, what does this factor to? So you might recognize that this is a special number, perfect square. So it's x plus 2, x plus 2. If you didn't, you might remember the attic basement, that this is A and this is C over here, so you have negative 4x squared. There's no B, the basement is 0. So you get what two numbers multiply to negative 4 and add to 0, and you got negative 2 and positive 2. Same two numbers. So if you're at the point where you just looked at x squared minus 4 and you got this, then you're in really good shape. If you're one of those that's going to come in tomorrow and say, oh, that homework is easy, it took me like 20 minutes, maybe less. Because you can just look at these things and factor them quickly. But if you stare at this and eventually got it, or if you stare at this and you didn't get this at all, it's all review. This isn't something new I'm teaching you how to do. You got to get better at it. And that's exactly what you promise to have. Practice this. Same thing here. Which number multiply to 3 and add to 4? Be careful. Make sure you use the right variable. This one's k. Again, k plus 3 and k plus 3. If you had to, you went off to the side and said, what numbers multiply to 3k squared? Add to 4k, and that's how you got 3k and 1k. And then you can finish the blocks and get this. You can do this rather quickly. It'll be very good. Let me talk to you about what the new thing is. There's one thing that was new that I mentioned, that was excluded values. So excluded values has to do with, in math in general, I'll say all math classes, all math. Okay. There's a golden rule in math. One thing you can't do no matter what. Not divide by what number?
0.
0. Not divide by 0. Okay. In any math class. So when we start having variables in the denominator, we're so used to just not caring what the variable equals. But if we have variables in the denominator on these problems, since we're doing practice now, there's a possibility that these variables could equal 0. So we have to avoid dividing by 0. So excluded value, I should say value or values, okay, are numbers that make the denominator that's what excluded value is. So mathematics not allowed to have divided by 0. Excluded values are saying, well, these variables can equal anything except these number, this number, or these numbers that make the denominator equal to 0. So you're going to see on a lot of these problems, it's going to have two parts. It's going to say simplify, and then also say state the excluded values. You really should do part 2 no matter what. If it doesn't say it, you should really do it no matter what. Here's what you do. Part 1 is just simplify, just like the warm-up. So if you know how to simplify this. So what does that equal? Let's say 4. 1 over 4. You start speeding up and going too fast, that's when you start making mistakes. So you know 48, you factor 48, that's 12 times 4. So the 12s cancel out, and that's how we get a 4 on the bottom. And then what about the a over 8? That's the third. So that's part 1. We simplified. Anything we can cancel, we did. Second part, excluded values. So down here, looking only at the denominator, what can make this equal to 0? What number, if we plug in, will make the whole denominator equal to 0? 0. Yeah. So a cannot equal 0. Say a cannot equal 0. That's the excluded value. Because if you plug in 0, 0 squared would be 0, 0 times 4 would be 0. Another way of looking at it is whatever's on the bottom, the denominator here, just set that whole thing equal to, or not equal to 0. You don't want it equal to 0. And then when you solve this, you'll get 0. Divide both sides by 4, and take the square root of both sides with 0. So there's part, that's the answer for part 2. That's the excluded value. What number makes the denominator 0? Go ahead and try this one on your own. Yeah. Do both parts, simplify, and the excluded value. See what you get, and then check with what I do. Not wait for you to write it down. We'll just talk it. We'll try it on your own. This, like that. And then lastly, you notice how there's 2 variables on the bottom? So in this case, we just say neither can equal 0. Neither can equal 0.
Is it always going to be 0?
So when will they be something other than 0? That's when we have adding and subtracting on the denominator. So right now it's just multiplication, multiplication. If you ever just have multiplication only, the excluded values will be 0. Remember, this is only when you have variables on the bottom. If there's no variable on the bottom, there's no way the denominator can divide by 0. You don't have to worry about it. So that's the more basics. There's no adding, subtracting. As you saw in your homework, though, most of them, like here, the first 4 are all multiplication. So yeah, for the excluded values will be 0s for here. Once we get to adding, subtracting on the denominator, then we'll have other numbers. Because if you plug in 0, let's say in number 29, you plug in 0, Well, 0 plus 2 is 2. That's fine. If negative 2, that will be excluded because negative 2 plus 2 makes the whole denominator 0. So whatever number makes the denominator 0. Do one more practice. So can we factor the top? Is that a factor or no? Part of factoring is knowing what does not factor. The top does not factor at all. What about the bottom? What does that factor? It doesn't factor at all.
Minus 3, m plus 3.
And minus 3 and plus 3. Okay. Again, some people know this like mentally really fast when you have to think about it. You'll see that when homework will finish so same idea as with numbers. So kind of like here's what we're doing, the equivalent of numbers. You guys did in like 5th grade. You did this. You said, oh, what does this equal? And this is like the original answer. And then you said, oh, at the bottom, you can rewrite this as 8 times 2. It's kind of like the bottom here. I'm rewriting this as 2 things being multiplied. And now something is identical on the top and bottom, so they cancel out. Something's identical on the top and bottom, so they cancel out. You're left with 1 over 2 here, so the same thing here. We're left with 1 over n minus 3. So it's the same exact rules as you learned in elementary school. It's just now we have to factor polynomials instead of just simple numbers. But the rules are all identical. What is the excluded value here? We don't want this to equal 0. What number would you plug in here in order for the whole denominator to equal 0?
0.
0 minus 3 is negative 3. That's okay.
Negative 3.
3, right? So if m equals 3, 3 minus 3 would be 0. So on this one, we say n minus 3 cannot equal 0. Denominator cannot equal 0. That means m cannot equal 3. So the excluded value is just 3. So whatever the denominator is, set it equal to 0. And if there's adding subtracting, it's going to be some other number other than 0 as the final answer. And it's possible to have 2 answers here too. We could get a quadratic, we'd have to leave a square or quadratic formula possibly. Or we could have any sort of equation down here. I think for today they're going to stay simple though. Okay. So hopefully you see the parallels here between what we're doing here and what you did years ago, and that's the same steps. Break something into factors, that means things being multiplied. And that way you can cancel them out. Whether it's numbers, you rewrite it as 8 times 2. Whether it's polynomials, you rewrite it as n plus 3 times n minus 2. It just has to be multiplied in order to cancel. Let's try another. Write that down. Go and factor the top, factor the bottom. And see what you get. Right on there. You know how to factor, right? So next year when you finish, you can do the same thing. You might have already caught on to this, but if you're writing these problems, what would you have to make sure happens? What's the whole purpose of all these problems? You're the one creating what problems should be on the homework. You're trying to make sure that something cancels, right? So if you get a p minus 2 on the bottom, you can use that as like a hint that that's probably going to be one of the factors here, negative 2. Not absolutely, because some things don't reduce, but probably if they want you to practice factoring and then canceling, well, one of these would have to be a p minus 2. With that in mind, it might help you a little bit coming up with the right number. What's the number multiply with 12 and add a negative 8? One of them's probably negative 2. Oh, the other one would have to be negative 6. And, oh, yeah, that works. So, yeah, we get p minus 6 and p minus 2. And sure enough, that will cancel. What is the excluded value?
0.
And for this one, excluded value is none. So, going back here, what is excluded value? Numbers that make the denominator equal to 0. Does this fraction have a denominator? No. So it can't be made equal to 0. So you have to know, again, what these excluded values are, what they're for. We're trying to prevent dividing by 0. So whenever you have a variable and denominator, then you have to worry. But if there's no variable in the denominator, you don't have to worry about dividing by 0. Okay. Before we move on, I want you to plug in a little sidebar. Take this original problem. Go ahead and plug in t equal to 1 into it. And then simplify, see what number you get. So plug in 1. Say you're trying to graph this. Plug in 1. Again, do it on your own. See what you get. Don't wait for me to do it and copy it down. See what you get. We'll operate. Probably got negative 5. Is your arithmetic correct? One minus 8 is 7. Negative 7. Negative 7 plus 12 is 5. 5 by negative 1 is negative 5. So that's what happens when you plug in 1 into the original problem. Plug in 1 into our answer, and what do you get? Negative 5. Well, why is that? Because these are equal to each other. This and this give you the same answer. That's what equal means. So, how is this useful? What is this useful for? Well, think about every time a new phone or new computer comes out, it's usually faster, right? That's why people want to buy the new thing, because it's better and faster. How do you make a computer or a smartphone faster?
New hardware.
What does that mean? What is it doing different than the last one could? Right? So sometimes it's something like mechanical, but with this digital age, it's more likely that the computer programming is just faster. How is it faster? Well, for any app or phone call you make or internet site you visit, there's a ton of calculations. And to make those calculations, if you have something that's rather big and lengthy like this, you see how many steps it is to get to a final answer for that to show up on your screen or whatever. So if you know how to take something that's big and complicated and simplify it to something that's simple, but still gives you the same exact answer, and that's how you can speed up the software, speed up an app, speed up a computer. You can do the same calculations but faster using a simplified version. The trick is figuring out how to simplify things that are complicated into something that's a lot more simple. And if you can do this, this is a career. You can do this for a living. Now they get paid a lot of money, so usually a lot of money at Microsoft and Google and Android and Apple is to write computer code that they can take things that are rather complicated, simplify it so you get the same exact results, but since it's smaller and more simple, the computer can process it faster, you can get the results quicker. So that's a career right there in computer programming. Just simplifying all the steps. Take something that's 4 steps, turning it into 1 step. Someone will pay you $100,000 a year to do this one. So a lot of math involved. So, do a few more, that practice. Make sure we remember all our steps. Scroll back to the very beginning. What was the golden rule as far as back here? What's the first thing you always do? Before we did the box or anything, what did we do? Yeah, do the GCF. So if ever you're doing the box, if you did a lot of things, you found out you're supposed to find which number is multiplied to 342 and add to 75. Chances are you skip the first step of doing the GCF. Don't skip that step. You'll find out the numbers are a lot smaller. So same thing here. Look only at the top. Is there any number that goes with both of these? Yeah. So we divide out of 2 on both. Divide each of those by 2. And this is just the reverse of the shift problem, right? Instead of multiplying in the number, we're dividing it out. So divide each one by 2, and we have b minus 7. And then on the bottom, what do we got here? Again, use the top as a clue. If we're trying, the goal is to cancel stuff out. There's a b minus 7 on the top. That more than likely will be a factor on the bottom as well, in order to have something that can cancel. Exactly. So we have what two numbers multiply to positive 14, add to negative 9. Knowing we have a negative 7 already, oh yeah, I just need a negative 2, and that works out. So we have a b minus 7 and a b minus 2. So use the already factored portion as a clue for the other part. It might help you. But sometimes they won't cancel at all. You might get to a point where you factor everything, and nothing cancels at all. That's okay. Like, similar to here, you might get to like 15 over 16. Does that reduce? Does 15 over 16 reduce? No, but you could factor it and see that, 3 times 5, 4 times 4. Yeah, nothing cancels, nothing's the same on top and bottom, so yeah, for sure it doesn't reduce. So you might go through a lot of these and see that after you factor everything on the top and bottom, nothing cancels, nothing's the same, and that's okay, as long as you factor and show that nothing cancels. Here we have that. So what's left over on top? What's left over on bottom? So here's the kicker. Does this cancel? Does 2 and 2 cancel? No. Right? So to verify that, how would you know to verify that? Use real numbers. So let's say b equals 10. Okay? What does this equal? That'd be 2 over 8, which equals 1/4. Alright, now let's take the same problem and just cancel the 2's out. What do you get? Yeah, 1 over 10. It's not the same thing. It only cancels if you get the same answer. So that's proof right there why you cannot cancel this. So what are the rules for canceling? Okay. You have to be multiplying. If you're multiplying, it cancels. But here it's subtraction. It does not cancel with this number up here. Only factors, things that are being multiplied. Okay, like we did. Oh, don't forget excluded values. What's excluded value here? show that the denominator cannot equal 0, and once we add 2 to both sides, you get b cannot equal 2. You could probably just look at this and tell, like, oh yeah, 2 minus 2 is 0. Let's see if it gets 2. If you can do that, that's fine. I don't require you to show all the little steps. Some of them are easy, some of them are not. Make sure you have both of these, the simplified answer and the excluded values. And if it says state the excluded values, make sure you state them. One more, and we'll be ready to go. Give this last one a go. Write it on your own, see if it can work for someone else and get it. All right. So what's the first step?
Factor.
What's the first step of factoring? UCF. Make sure you do that first. So you're looking at only the top, seeing if there's a number that's similar in all of them. Looking only at the bottom, seeing if there's a number that's similar in all of them, dividing it out evenly from each one. The same thing we did back in the 7th grade and 8th grade, right? So it's not new, it's just you got to remember to not skip straight to, well, what two numbers multiply to 72 and add their 18. You don't want to do that. If ever you find yourself working too much, like the numbers are too big, always go back and ask yourself, did you get big out of GCF? That always makes the numbers smaller. So you'll get, so you get a number 2. Right? And then you go further. Say, can you further factor those factors? And if so, does anything cancel? The last thing you'll do on every single one of these is cancel. If at first, when you have adding, subtracting involved, if you cancel anything from the beginning, you're done. It's already wrong. It's already messed up. You're missing the point. And you have to remember, you have to write things as multiplication in order to cancel things out. So the only things I can cancel will be a 2 and whatever these two parentheses come out to. If I don't get any of those on the bottom, nothing cancels. But you have to be multiplying in order to cancel. This is all adding, subtracting. Nothing can cancel at this point. And dividing everything by 2. You got this. The bottom, you got divide everything by 3. You got this. Minus x. Minus 12. What did the top factor to? Yeah, 1 multiplies 18 and adds 9. 6 and 3. And then, when you went to factor the bottom, you were kind of looking for a 6 or a 3. Positive 6 or a positive 3, because that's the only way something will cancel. And what did the bottom come out to be? Negative 4 and 3. So yeah, they both had x plus 3 in common. And now we know those cancel out. Now, can the 2 cancel out with this 4? No. Can the 6 cancel out with this 3? No. So that's what's going to mess some people up, is that they're so used to these having this, small answer, they're not going to be comfortable having all this stuff as a final answer, and they're going to force things to cancel out. Don't do that. Just say the only thing that can cancel out with the top would be 2. There's no 2 on the bottom. and x plus 6. There's no x plus 6 on the bottom, so that's it. Has to be identical to cancel out. One more step, what's the excluded value? What makes the bottom 4? I mean, what makes the bottom equal to 0? 4, yeah. X was equal to 4. 4 minus 4 would be 0. And we can prove that just by doing this. We know that x plus 4 cannot equal 0. Therefore, add 4 to both sides. X cannot equal 4. X is equal to 4. And we plug it in. We get a 0 denominator, and we can learn how to calculate it. So make sure you do both parts. Simplifying and the excluded value. Gotta have both. In the back of the book, you'll just see the answer, and there'll be like a semicolon or a comma or something, and then 4. Okay, so that just means that's the excluded value. All right. So your homework. For tonight. 11-2, page 586. That's another 586, and we're doing numbers 1 through 39 odd. Okay. Plus, check Bob.
Who's Bob?
Who is Bob? Back of book. These are all odds. So when you come here tomorrow, your answers are correct. You check as you've gone along to make sure you're doing them correctly, you reduced everything correctly. If there's an answer that doesn't match yours, you're not going to say, oh well, you're going to go back and see what you did wrong on the factoring. And if you have to, you're going to work backwards. You say, well, if I know this is the answer, that means this has to cancel. If this cancels, that means this would have to be like a +3, not a -3, like I wrote down. So you're going to do everything possible to make sure you're going to get all the excluded values and all the factors correct, and each one. And then tomorrow in class, you're going to do this. Unless you're taking the final, look if you're absent. 38 even. You're going to do all the evens where you don't have any answers. So you're on your own. But again, after doing this thoroughly on the odds, you'll be ready to go. So both of those. Absent if you're absent yesterday, you're taking the final tomorrow. If you're absent during the final last Friday.